So here we are, question 51, bit of factorisation, a question all about the x factor. Let's see how you got on with this one. Here's the question then. Now this comment here about you must show your workings, that implies that we need to use a method to solve this problem, not just simply our calculator, graphical calculator or what have you. So the method that I would use here is the factor theorem. So to start with, I need to find a factor. So I'm just going to guess values. Start with f of 1, for example, and that's equal to 2. But I might be thinking at this stage, actually, it could be a while before I get the right guess. So I'm going to use table mode in my calculator to get a range of different values of f of x for values of x. So if you're not sure how to do that, that can save time. If you work out how your calculator can do that, that can save time in the exam. And my calculator told me that f of -1 was 36, but then bingo, f of 2 is equal to 0. So that indicates that x minus 2 is a factor of f of x. So we found a factor, we've got to find the other factor or factors. And there's a number of different ways you can go about this. One of them is algebraic division. I'm going to choose a slightly different method today. So what I'm saying is that this function f of x, I'm making it equivalent to my factor that I know is there, the x minus 2, and if it's equivalent to that multiplied by something else, then the something else must be a quadratic expression, and I'm trying to find the values of a, b and c. So the first thing I do is to multiply out the brackets and group the like terms, and then I can compare the coefficients. Comparing the coefficients of x cubed to start with tells me that a must equal -1 straight away, so I get a quick win there. Then I can compare the coefficients of x squared on both sides, because this is an identity. 7x squared, so 7 must be the same as b minus 2a. So that gives us b equals 5. Now, some people then go straight to the end and they say, we can compare the independent terms and get the value of c, but I prefer to do a belt and braces on this one. I prefer to look at the coefficients of x here. So I would say that -16 is c minus 2b to start with, which gives c equals -6, and then finally by comparing the independent terms, I get my opportunity to double check that my answer is correct, the -6 is correct. So I come away feeling happy that I've found the quadratic factor. But of course, this isn't the complete factorization yet. It could be that the quadratic factor doesn't factorize, but let's have a look what the quadratic factor actually is. So there's the quadratic factor. When I put the values of a, b and c back into that original expression there, then I can see that the quadratic factor does factorize in itself. And I like to take the negative sign outside of all of the intermediate brackets, so that I've got 3 factors like that. So there we are, there's the factorization. Have we finished the job yet? Let's go back to the top of the question. Factorize f of x is that. So we've done that. Don't forget the second part, hence sketch the graph. So the sketch then, let's have a quick look at the sketch. Here's my x and y axes, and we've got repeated roots here. Our roots are 2, 2 and 3. We've got a repeated root of 2. So that tells us that the cubic equation, or the graph of the cubic equation, doesn't go through the x-axis at 2, it bounces at 2 here. But it does go through the x-axis at 3. It's a negative cubic, so it's this shape rather than this shape. And we can also quickly check where does it go through the y-axis. Well, we can do that by setting x equals 0, and we get y would be equal to 12. So we're starting off up here at 12. Well, actually, we're going through the y-axis at 12, bouncing here, and then going through there. So it's something like that. You can probably make it a little bit smoother than my scribbly drawing there. So that's the answer to the question. How did you do? Did you use the same method or a different method? Did you get the same answer? If you did, well done.